The figure shows the difference between initial and final design. Initial design was made simple following the conventional method, but due to the increase in the height, the stability of the robot was compromised. Here, the omni-wheel is coupled directly to the axis of the motor. The new design was made with reduced height with the implementation of bevel gear mechanism where the axis of the wheel is placed perpendicular to the shaft of the motor. The figure shows the prototype model made of aluminum sheet metal as chassis and later on made to 2 mm thick mild steel material. Bevel gears of 20 mm pitch diameter was 3D printed from PLA plastic with 20 teeth and later increased to 35 mm to increase the load capacity. The simulation of the model was made in MATLAB in which the physical model of the system was made and the motion was studied. A ball is used to mimic the motion of the system over a plane.
The final fabricated model of the test bench is shown with optical mouse sensor used to measure the motion in X and Y direction. The figure shows the optical mouse sensor used to measure the motion in X and Y direction. The ball is made to rotate in Z axis with the input given through Arduino programming. Now the ball is made to move in X axis with the input again given through Arduino programming. The IMU sensor is used to control the motion of the ball in the plane. As the sensor is moved to 0 degrees, the ball rotates at 0 degrees along the X axis. Now when the sensor is moved to 90 degrees, the ball is also moved along the Y axis at the same angle. Similarly, for 180 degrees and 270 degrees, the test is repeated. The sensor is then mounted on a structure to place it according to the angle.
The entire prototype is then inverted to place on the floor and the motion is tested based on the given inputs. The inputs include various angles as shown before as well as the different velocities. A frame is made to hold the robot from even the event of a fall and help it during the testing.
Yes,